Welcome to this video where we're going to cover the in-class activities, the solutions to those. And we're going to first start with part A. So the first question was the dynamic equilibrium can be defined as. So we're looking at in a situation for like salt dissolving. So sodium chloride being added to water, so making salt water, so sodium chloride, so the aqueous. So going in the forward direction, we're dissolving, so this is dissolution. And if we're going in the reverse direction, it's deposition. So you can add so much salt that eventually it gets saturated and some of the salt will no longer dissolve. And so you have this equilibrium that gets established. So a dynamic equilibrium is defined as the rate of dissolution equals the rate of depositions. So the rate of the reaction going this way in the forward direction equals the rate of the reaction going in the reverse. So it's not necessarily equal amounts, but it's an equal rate of reaction. So that's the important part, equal rates of reaction, how fast the reaction is going. Then in question 2, we're looking at what dissolving is. So that same situation with the sodium chloride being dissolved in water. So dissolving is a process where sodium chloride starts to dissolve in water, and it's a one-way reaction. So eventually, if you add so much that it becomes saturated, then you'll get an equilibrium established. But before that, as it's dissolving, the rate of dissolution is faster than the rate of deposition, or going in the reverse. So not until it gets saturated and it reaches equilibrium will it be the same, but before that we get to that equilibrium, the dissolving is going to happen at a faster rate than the deposition. And again, if you need a reminder with those greater than or less than signs, the alligator eats the bigger number. Okay, so in question 3, we were asked to express the equilibrium constant for the following reaction. So with these, it's products over reactants. So our products multiplied by each other over our reactants, and the reactants are multiplied by each other. But all the coefficients become the subscripts. So notice how I took this product, the 2 out in front became an exponent, times the hydrogen, and there's an understood 1 for the hydrogen, and there's an understood 1 for the exponent, divided by the reactant, so the CH3Cl. Oops, my L is missing right there. And it's squared because the 2 out in front, and then the divided by the Cl2. So that's how we're getting D for the answer. So products over reactants, coefficients are converted to exponents. All the products and the reactants can be expressed as concentrations, either molarity or partial pressures. And that's true because these are gas, so none of these are solid and none of these are liquid. Because if they're solid or liquid, we can't express them as pure, so they're not going to show up in the reaction, but we can have partial pressures of gas. And then in 4, give the direction of the reaction is if K is much, much larger than 1. So if we've got K and it's products over reactants, to get a very, very large K, we're going to have a lot more products than we do reactants. So if we've got more products than we do reactants, the reaction favors the products. So it favors going in the forward direction.